And today we are going to talk about diffusion of fluids. Okay, before we start our session, I need you to see this video. So we have cold water and hot water, and we add the solution, this color solution. So this solution is spread inside the liquid, the water, and spread to inside the hot water. But as you see in hot water, spread very fast. Okay. You can see the difference in hot water, diffusion taking place very fast, while in cold water, it's a little bit slower. When you add an acid like vinegar, the color can appear now, and as you can see. And now you can see that this concentration is more than that, means that here is the color liquid is more than here, but it was diffused very quickly because of the effect of the temperature. Okay, so diffusion is a sort of spreading a compound from a high concentration to low concentration. Okay, particles move from a region of higher concentration towards a region of lower concentration. Like when you see it first spread to the areas in water that has no any other particles. So it moves from higher concentration to lower concentration. Okay. And after that, after complete spread from the higher concentration to lower concentration, the particles will keep moving towards the lower concentration until all the concentration of the whole container of the whole liquid will be the same. So rate of diffusion in liquids is much slower than gas. So diffusion in liquids are slower than gases. And no diffusion in solids. Solids cannot diffuse liquid or gases. Okay. Because the solid particles are moving in place. They could not move from a place to a place. So what is diffusion? Diffusion simply is a process by which different fluids mix together. This fluid can be gas or liquid as a result of the random motion of their particles. And their particles move from higher concentration to lower concentration until the concentration is equally distributed over the container. So what is dissolving? Let's see what we have here. This is, as you can see, spreading from higher concentration in the middle to the lower concentration to the edges of the container. And at the end, you will see this container has the same color. The liquid will have the same color, which means the concentration is now equal everywhere in that solution. Let's talk about diffusion of gases. That's literally what happened. If you are walking up beside a restaurant and there is a very tasty smell, okay, from where that smell come? From the food which is inside the kitchen, which is inside the restaurant. And how this smell come to you while you are outside the restaurant? Because this smell is like a vapor or a gas, particles that dissolve or spread and diffuse in the air, in the surrounding air of the area of the surrounding area, and then and that's why we smell it. Yes, that's what happened exactly. So, an experiment, diffusion of bromine gas. We bring a cylinder which fill with bromine, okay, and we put another cylinder over it upside down. And when we allow both gases inside the two cylinders to mix together, we will see that bromine gas is moving from the high concentration in the lower tube to the low concentration in the upper tube. And this diffusion will continue until we can see both tubes have the same color, the same color degree, which means is now that the concentration of the bromine gas is equally distributed over the whole space of the two tubes. Another experiment of ammonia and HCl. So one of them will diffuse faster than the other. Okay. And how we know that? We will see. There's concentrated hydrochloric acid. We will take some of them and put in the cotton at the top of the first at the top of one side of the cylinder, and the ammonia will be added in the other side, in the opposite side of the tube, and both tubes are covered from both sides to avoid any escape of gases. Usually, as we know that ammonia NH3 plus HCl, which is a concentrated hydrochloric acid, when they react together, they will give ammonium chloride. And the color of ammonium chloride is white. Okay. And the ammonium chloride will be formed when ammonia meet the hydrochloric acid fumes. Okay. Here is the ammonium chloride is formed. Okay. Which means that ammonia travel faster than hydrochloric acid, which travels very slow, which means that the fusion of ammonia was faster than the diffusion of hydrochloric acid. How do we know that? We know that because we can see the formation of the ammonium chloride in H4Cl at this area. And as we can see, this is the area where ammonia meets the hydrochloric acid to react together. And we can see that ammonia travel longer than HCl in the same time, which means that ammonia has a higher diffusion rate than the hydrochloric acid. So diffusion of gases, as explained according to the kinetic particle theory, okay, heavier gas particles move more slowly than lighter particles at the same temperature. When the particles of the gas is heavier, so they will travel slower. And if the particles of the gas is lighter, they will travel faster. Consider you and your friend. Your friend is fat and you're thin. The fat person will run slower, while the thin person will run faster. This is the same idea. The same idea, we can say that the larger molecules diffuse more slowly than smaller ones. Okay, so as the size and as the mass of the particles increase, the diffusion rate decrease. So the rate of diffusion is inversely related to the mass of particles. As the mass increases, the diffusion decreases. The average speed of the particle increases with an increase in temperature. When we increase the temperature, we give energy. If you remember, we give haste energy to the particles, so the particles gains more energy, which allow it to move faster. Yeah, I hope you understand this session. That's all for today.